right, so on to our next lesson with our new big idea, remember, because we've got two for this unit, is developing number sense. So number sense is demonstrating an understanding of multiples, factors, and prime and composite numbers, how different ways that we can look at numbers that help us to describe and solve problems in the real world. Today we're focusing on prime and composite numbers. So numbers are multiplied to form a product and are factors of the product. So for example, if we are trying to find out factors of 28, two numbers that multiply to equal another number are factors. Okay, so 2 and 14, for example, are factors of 28. 2 is a factor, 14 is a factor. Factors are anything that multiplies to equal that number. Equaling the answer is the product, so 28 is the product. We're going to skip the Explore section for now. You will go back to it once we are finished. So, for example, suppose you have 23 colored tiles. You can only make one rectangle or one array. We can only find 23 by multiplying 1 times 23. That's the only way we can make 23 with multiplication. And with factors, it's always with multiplication. With prime and composite, it's also always with multiplication. So that means that 23 is in fact a prime number because the only way we can find it is by using two factors, 1 and itself. A prime number is a number greater than 1 that is divisible only by 1 and itself. So the only way to make that number is 1 times itself. Okay, that makes it a prime number. Now let's assume we're working with a different number and we're working with 24 tiles. We've just added one more. But now we can make 4 different rectangles. We can always have the 1 times 1, so 1 times 24, big long one is 24. But we could also have 2 rows of 12. 2 times 12, 2 groups of 12 does equal 24. We could also have 3 rows of 8 or 3 groups of 8. That also equals 24. And we could also have 4 groups of 6, which would also equal 24. So there's lots of different ways that we can multiply to equal 24. That means that 24 is a composite number. Okay, it is a composite number. All right, and this will help you in your next unit, but they have it in this connect section as well, and it certainly doesn't hurt to look at it twice. When we are finding factors, factors, remember, are two numbers that multiply to equal that number. And in this case, we're looking for factors of 40. So we could use multiplication facts to help us find that out. So we're looking at numbers that multiply to equal 40. Okay, so 1 times what is 40? Well, 1 times 40 is 40. 2 times anything equal 40? Yep, 2 times 20 is 40. 3 times anything equal 40? Well, if you look at your 3 times tables, no. 4 times 10 equals 40. 5 times 8 equals 40. 6 times anything equaling 40, 6 times 6 is 36, 6 times 7 is 42, so no. 8 times anything, well, yeah, we've got 5 times 8 equaling it. 9 times anything equal 40, well, let's think of it. 9 times 5 is 45, so that's too big. 9 times 4 is 36, that's too small, so it doesn't equal 40. So 40 has 8 factors, 40, 2 and 20, 4 and 10, and 5 and 8 are all factors of 40. Now let's take a look at 18. Here she's trying to find all the factors for 18. Well, it's always 1 times something, so 1 times 18. 2 times anything equal 18. Well, 2 times 8 is 16, 2 times 9. Oh, yep, that's 18. 2 groups of 9 equals 18. Perfect. 3 groups of anything, 3 times 6 is 18. Perfect. 4 times anything, well, 4 times 4 is 16. 4 times 5 is 20. Nope. 5 times anything, 5 times 3 is 15. That's too small. 5 times 4 is 20. No, that doesn't work. 6 times anything, 6 times 3, and we've got that one already. Perfect. 7 times anything, 7 times 2 is 14. 7 times 3 is 21. Too big. 8 times anything, 8 times 2 is 16. 8 times 3, 24. Too big. 9 times anything, 9 times 2. Yep, we've got that already. And so we don't repeat those. We already have it. So the factors of 18 are 1 and 18, 2 and 9, 3 and 6. And if you go from 1 to 9, you should have all of the factors. If it has more than 2 factors, more than just 1 and itself, it is a composite number. If it has more than 2 factors, not just 2 factors, more than 2 factors. A prime number only has 2 factors, 1 in itself. That's a prime number. Composite numbers have more than 2 factors, more than 2 in itself, so at least 3 factors. All right, it looks like my practice somewhat overlapped here, so I've rewritten it up here. Prime or composite. Try to figure out if a number is prime or composite. You're looking at 15, 57, and 96. Go ahead and press pause right now and try to figure out which is prime and which is composite. And be ready to have an explanation. Why is a certain number prime? Why is a certain number composite? Remember, you will be using this very regularly on your number work. So you want to make sure that you've tried to practice it, see if you understand. Go ahead and press pause now. All right, let's take a look at those numbers. So we have 15. 1 times 15, of course, equals 15. 2 times anything? No. 3 times anything? 3 times 5 is 15. Oh, so right there I can stop because I already know that it is a composite number. 57. Oh, tricky. Okay, so 1 times 57, yes. 2 times something? No, it's odd. 3 times something? Oh, that's tricky. I think I might have to punch that into my calculator. So let's try that. 57 divided by 3. Ooh, I get 19. So 3 times 19 equals 57, which wouldn't have been one I thought of. So often try 3, try 7, try 6. Some of those will work even when you think, automatically when you look at it, it's like, oh, there's nothing that multiplies to equal 57. When I think of my basic facts, I can't think of anything that multiplies to equal 57. But remember, it might not just be your basic facts. It could be a smaller number and a really big number, like 3 times 19. So in fact, 57 is composite. 96, well, it's even, so I'm thinking it's probably composite, but let's double check. Of course, 1 times something is going to equal 96. 96 is a big number, so I'm going to punch it into my calculator. 96 divided by 2 equals 48. So 2 times 48, so I know it's automatically composite. Well, what kind of numbers are prime? Can you take a moment and list for me at least 3 prime numbers? Go ahead and give that a try. 3 prime numbers. Pause and do that now. All right, what kind of numbers could be prime? Well, let's go through. 1, remember, is a special number. It's actually not prime and it's actually not composite. It is special. So is 0. Because 0 you can get by 0 times 0. It only has 1 factor. It's 0. Same thing with 1. 1 times 1 is 1. It only has 1 factor. That's 1. So it is a special number. 2. 2 times 1, nothing else. So 2 is prime. 3. 3 times nothing else. 3 is prime. 4. 4 times 2, not. 5. 5 times 1. 2 times anything. 3 times anything. Nope. So 5 is prime. 6. Well, 3 times 2, so it's not. 7. Only 7 times 1. It's prime. 8. 2 times 4, so no. 9. 3 times 3, so no. 10, 2 times 5, so no. 11, ooh, only 1 times 11. 12, 2 times 6, no. 13, yep. 14, 2 times 7, no. 15, 3 times 5, no. 16, 4 times 4, no. 17, 1 times 7, yep. 18, 2 times 9, no. 19, yep. 20, 2 times 10, 21, 3 times 7, 24, 3 times 8, 25, 5 times 5, 26, 2 times 13, 27, 3 times 9, 28, 4 times 7, 29, nothing, so 29, 30, 3 times 10, 31, nothing, 32, 4 times 8, 33, 3 times 11, 34 is even, so 2 times something, 35, 5 times 7, 36, 6 times 6, 37, maybe, let's see, maybe I'll punch some things into my calculator here. 37 divided by, well, it won't be even, so not 2, maybe 3, nope, that's 12.333, so that's not going to work. 37 divided by 4, well, it's not even, so that's not going to work. 37 divided by 5, not 5 or 0, so that's not going to work. 37 divided by 6, unlikely, no. 37 divided by 7, possibly, no. Okay, it's prime. 38 is even, so you can do 2 times something. 39, oh, 39. Well, 39 divided by 2, no, it's not even. 39 divided by 3. Ooh, 3 times 13. So it's actually composite. So sometimes you really have to look carefully to determine if a number is prime or composite, because usually when we look at 39, we would assume definitely prime. But it's not. You cannot assume. You have to actually check and go through those numbers from 1 to 9 to see if anything will multiply to equal it. And sometimes you'll use your calculator and you'll divide and you'll see, is it an even answer or is it a decimal number? If it's a decimal number, it does not work. All right, at this point, it looks like you're ready to move on to your concept practice. And I know it's down here. Concept practice, remember, practice is your skills, becomes homework. We will mark and discuss it. It is page 61, numbers 2, 5, 8, and 9. You are working on demonstrating an understanding of prime and composite numbers. And I want to see this kind of work to indicate that you have truly found a composite number. I want to see some of the numbers you tried, like I did in my head for 37. So maybe write some of those down. Well, I tried times 3, it doesn't work. Tried times 4, it doesn't work. And so on. So there has to be some evidence of what you've done. Make sure you are showing your work. Go ahead and do your concept practice now.